All right, welcome to part 2 of this video of motional analysis of x, v, and a, right? Okay, in this one we'll discuss the relationship between the signs between velocity and acceleration and the object's motion. So in number 1, the velocity, which is defined as the change in position over change in time, right? That object was moving to the right. So say from position 1 to 2, right? It's increasing speed, but for right now, the delta x is positive, right? Because to the right is positive. The acceleration, delta v over delta t, well, what's happening to the change in velocity? It's speeding up. Well, that means it's increasing velocity. So that's also positive. In number 2, the velocity is doing what? Well, yeah, velocity is doing what? Let's see. Well, what's happening to the position? The position is still towards the right, right? It's still from position 1 to 2. So in this case, the delta x is positive, making the velocity positive. And by the way, you can put vector bars over top of these arrows. Vectors will come in next chapter, but these bars here denote direction. Okay? So, for example, this x with a bar over it, that is displacement. X without a bar, that's distance. Similarly for v, right? V with a bar over it is the velocity. V without a bar is just speed. Okay? The bar denotes a direction. So for the acceleration, that's delta v over delta t, the change in velocity over change in time. What's happening there? Well, the object is slowing down. So delta v is decreasing, so that's a negative. So in between v and a, when the velocity is positive but the acceleration's negative, it's slowing down but moving forward. Okay. In number 3, let's see what's happening between the velocity and acceleration. So, all right, delta x over delta t. What's happening here, the position is moving to the left, right? This object is going towards the left. We can write position 1 to position 2. So the velocity is, well, the position is getting more and more negative, I'll say. So thus, that's a negative. Okay? For the acceleration, delta v over delta t, what's happening there? Well, it's speeding up, yes. However, it's speeding up in the negative direction. And that's important here. The negative direction is what gives us the negative sign out front, right? That's why we need the vector bars on top of our symbol here. This is a velocity, and it's negative because this object is moving in the negative direction. It has a negative velocity, in other words. So when both v and a are negative, that tells you that an object is speeding up in the negative direction. Okay? Speeding up backwards, for lack of a better term. And in number 4, let's see, v is delta x over delta t. What's happening here? The position now is still towards the left, so from 1 to 2, but it's slowing down. Well, delta x in this case is negative because it's still moving left. And acceleration, it's slowing down, right? So it's negative. However, well, sorry, let me back up. It's moving to the left, so its motion, its velocity is negative. However, that value is decreasing, right? So effectively, we have a negative, how do I write this? A negative delta V. Right? The motion overall is negative, but the change in speed is getting less. So it's a negative change in the velocity, I should say, not speed. So negative times a negative makes that overall a positive. Okay? And so when velocity is negative, but the acceleration is positive, that means that it's slowing down in the backwards direction, right? But what that qualitatively means, right, in other words, is that the object is really having an acceleration that's going forward. I'll write it like that. And I'll write V like that. Okay. Actually, let's do that for everyone, right? That's a good idea. I don't know why I didn't think of that earlier. Let's do it in blue. So we have V, and I'll do red for acceleration. That's the same direction. V for number 2 is positive, right? But the acceleration is negative. For number 3, the velocity is negative. And for and the acceleration is also negative. And then let me update number 4. I hope this will be a good visual for you to see the correlation between velocity and accelerations. Okay. And so again, in blue, the velocities are such that whichever direction the speed increases, right? For acceleration, in red, it's whichever way the change in velocity is pointing. Okay? All right. Well, that's it. Thanks for watching. The next video, the final video in this series, will be putting this all together in one graph to hopefully synthesize everything. Okay? Thanks for watching.